So in this set of videos, we're going to talk about something that sounds scary at first, but as you've been practicing with derivatives for so long, I use some of the stuff you already know in order to help you with this new thing. So we're going to talk about antiderivatives. All right, so what is an antiderivative? A function f, capital F, is called an antiderivative of a function lowercase f if you take the derivative of the capital and get the lowercase. Another way to think about it is you start with your f of x, you undo the derivative process, and you get the capital F of x. All right, when you're going backwards, there's actually more than one answer you can get, and that's because if you have f of x, you can always add 0 to it, and when you undo a 0 when you're doing an antiderivative, you could always get a constant, because when you take the derivative of a constant, you get 0. So when we take the general form of our antiderivative, I will have kind of the main part, the lowercase f turning into the capital F part, but we never know if there's this extra constant c at the end. So pretty much for all these problems, we're going to do a plus c at the end to take into account we don't know what that constant that turned into 0 could have been. All right, so if we want to find the antiderivatives for the following, again, at the beginning, it might be a little bit of guess and check. You want to make sure that your answer for capital F, if you do take the derivative of it, you should get the lowercase f. All right, so here we're doing some thing with powers. All right, 3x squared. We knew when we were taking derivatives, you subtracted 1 from the exponent. So when we're doing antiderivatives, you do the opposite. I'm going to add 1 to the exponent. And it turns out this one, if I take the derivative of x cubed, the 3 comes down and gives me that 3 I needed there. So that's going to be my answer. And again, I had to add that plus c because I didn't know if there was an extra term there. All right, for the middle one, now we're doing cosine. We're just doing our trigonometry wheel, but we're doing it in the opposite direction. So instead of cosine going to negative sign, we go in the opposite direction and we get sine. And if I take the derivative of sine, I get cosine, so I know that's right. I just have to add plus c. For e to the x, I know whenever I take the derivative of e to the x, I get back the exact same thing. So if I go backwards, I should get the same thing as well. All right, so capital F of x is e to the x. Again, double check if I take the derivative of e to the x, I get that, and I have a plus c. All right, so at the beginning, it might be a little bit of guess and check. I just got to make sure whatever you write down for your capital F of x, if I take the derivative of this, I get the function I started with. And that's the basic idea of antiderivatives.